Hello, welcome to Autodesk Netfabb Simulation, Lesson 7, Predicting Recoater Interference. The objective of this lesson is I want to explain how Netfabb Simulation calculates how close the deformed geometry is to interfering with the recoater blade. That means hitting the blade that rakes over the new layer of powder, which is a common cause of part failure in additive manufacturing. Then I want to run an example of a part that's going to trigger this recoater warning in the simulation. So before we get started, I want to explain the concept of recoater interference tolerance. So the output of how close you are to hitting the recoater blade in Netfabb Simulation is going to be given as a percentage. And how this percentage is calculated is as follows. So in this picture here, this gray material, this is the actual solidified geometry. And this blue space is the next powder layer. So if the software is calculating a 100% clearance, that means that none of the material that you've previously deposited has deflected upward into the next powder layer. So the blade is going to come across the top of this powder, and you're not going to hit any of the previous build. So an 85% tolerance would mean that your part has deflected upward into covering up 15% of the next layer. So now you have 85% of your space left before you're going to hit the recoater blade. Now by default, the software has a 20% recoater tolerance. So if the tolerance goes beneath 20%, you're going to start to get start to get warnings in your log files that will tell you that you're getting dangerously close to hitting the recoater blade and may actually hit it. So in that case, that would be 19% clearance would mean that we've deflected upward and we're taking up 81% of the remaining space. And then in a case where we've actually come through the top of that, the space for the next layer, that would be a negative tolerance. That means you're definitely going to hit the recoater blade. So now we're going to launch Netfabb Simulation and we're going to import a geometry. So we've covered this a lot in previous lessons, so I'll go through it quickly. All right, so this is the geometry that I'm importing. So, obviously something with this steep of an overhang is not going to be a good idea to build, but we can use this as kind of an extreme example to show how recoater interferences can be observed and how it's calculated. So now we'll just immediately hit the solve button and give this guy a name and hit save. So setting up this analysis and picking your parameters, that's been covered in previous lessons as well. So we'll import the results and we're going to play through this video. So you can see we bring in new material and it cools and contracts, follow through this pattern. And now when we get to the overhang, you can see that the part's actually going to start to lift up in the Z direction. So when you see lifting like that, that's an indication that it's possible that you've come up through the top of that, that's the powder bed, and could actually be hit when the recoater blade comes across to rake over that next layer of powder. So to check for that, we'll go to the Home tab and we'll do View Logs. And first we're going to look in the mechanical log file. So we're going to scroll down to the bottom of this file, and we're going to see that we do have one warning here. So I'm going to scroll up and I'm going to look for where that warning occurs during the run. And I can see here at my iteration at 6,700 seconds, I have a recoater warning of -2%, which means that I've infringed on all of the space that I had, and I've actually come out through the top of the powder layer, and I'm going to get hit by that recoater blade. So we want to see what's going on at 6,700 seconds here. So we'll go to results, and that's actually the next time step. So we can see now, as we brought in this additional material, when that material cooled and contracted and plastified, that deflected upward, and it actually deflected upward enough that it's going to interfere with the recoater blade. So now as a design engineer, you know that if this is not a critical feature, you can make a change to this geometry so you don't have such a steep overhang. Or if it is a critical feature, you might want to consider adding some support structures to anchor that feature down and rerun this through the simulation tool to make sure that you've avoided the recoater interference. And now we can go back also to the logs And I'll just show you that there's also a tab for Recoater blade interference. And what this tab shows is it shows what your clearance percentage is at all of the time steps in the simulation. So most of the way here, we were in the clear, so we had large positive clearances, which means we were safe. We weren't going to hit the recoater blade. And then here at -2%, that's when we actually saw our warning. And if we want to change how sensitive the analysis is to outputting these recoater warnings, we can go into Analysis Setup, the Analysis tab, and this is the recoater tolerance right here. So that defaults to 20%. We could put that to something really conservative of 50%, and then you're more likely to output those warnings. So to summarize what we went over, we explained the concept of recoater clearance, and we ran an analysis that resulted in recoater interference, and we went through how to identify that warning and to match that to the result that it corresponds to. So the next lesson I want to go over importing multiple geometries and supports into the analysis.